Of transformations. So example 1, the graph f is obtained from the graph of the function with root y equals to x squared. So therefore x squared will be the original function. If it's original function, try not to use fx. Okay, try not to use this notation. Use x and y notation. So let's write that into y equals to x squared. Okay, so that's the old y and old x. By a translation of 3 units in the positive direction of x-axis. So what you can write immediately is x dash will equals to x plus 3. Okay, the old x go right by 3 units, that will be the new x. So 3 units in the positive direction of x-axis. And translate 1 unit in the negative direction of y-axis. Okay, let me write to this corner because I want to save some space. So y dash will equals to y, a negative direction will be the old y subtract 1. Okay, the original graph go down by 1. So y dash equals to y minus 1. Write down the rule for gx. Okay, for gx, that's the new function. Okay, that's the resultant function. That's the new function. So you want to have equations in terms of x dash and y dash. Okay, in terms of x dash, y dash. Okay, that's the type 1 question. You have the original one and you have the transformation and ask you the resultant function. So because I have x and y, so I need to have x, y to be the subject. So x will equals to x dash subtract by 3 and y will equals to y dash plus 1. And I'll do substitution. Okay, that's step number, let's say that will be the step number 1 in terms of xy. Step number 2, step number 3, step number 4 will be substitute. So substitute that in, that will be y dash plus 1 equals to bracket, okay, x into the bracket, x dash minus 3 to the power of 2. So y will equals to x minus 3 squared minus 1. Okay, because the question is in terms of g, so you will say gx equals to x minus 3 squared minus 1. Okay, that's the first step. That's translation. Okay, that's translation. What happened in translation? That's gx. Okay. Part B. The graph of H is obtained from the graph G. Okay, obtained from the graph G. So graph G become the original function. Okay, graph G is your old function now. So you will write y equals to x minus 3 squared minus 1. That is your original function because H is based on G, okay, what you have in G. So G is the original function. And then you talk about translation now. So by dilate by a factor of a half from the y-axis. So a half from the y-axis, what I can write? A half from y. So it's changing what? X. So x dash will equals to a half of the original x. Okay, so it's dilate from y is changing x, so it's the new x equals to a half of the original y. Okay, from y is from this axis and I'll go inside. Okay, go narrower. Okay, dilate by factor of 2 is stretch it, so a half is narrower, so that will be x dash equals to a half of the original x. And the reflection in the x-axis, what is changing? Y. So what I can write? Y dash equals to, okay, negative y. Okay, everyone needs to think. Okay, do not just copying, it's not making any help. So from y-axis is changing the x value, x dash equals to half x, and reflect in the x-axis is changing the y value. Okay, this point come here, so x value doesn't change, so y become negative of that. And because I have x and y, so I need to make x and y to be the subject. So x will equals to 2x dash. Y will equals to negative y dash. Okay, I must make that into this form and I can substitute. Okay, and I can substitute. So y will be negative y dash and x will be 2x dash minus 3. The minus 3 is still there and the minus 1 is still there. So y will equals to minus 2x minus 3 squared plus 1. Okay, you minus both sides, the minus 1 becomes plus 1, and you have a negative of that. So hx, okay, this is h. So hx equals to minus 2x minus 3 squared plus 1. Okay, minus 2x minus 3 squared plus 1. That's your hx. So now what happened is you have a function f. Okay, after some transformation that become g. Okay, g after some transformation become h. Okay, and part C is say the graph k is obtained from the graph of function h. Okay, from h. Okay, f become g, g become h, and then h give k. Okay, k is obtained from the graph of h by translate, like, I don't care about what's the translation first. H is your original function now. So your old y equals to minus 2x minus 3 squared plus 1. That is your original function because h will give you k. Okay, h is the original one. Okay, what is the transformation? So translate of y units in the negative direction of the y x-axis. Okay, move down by 1 unit. Okay, move down by 1 unit. So y dash will be old y subtract by 1. Okay, move down. And dilation from the x-axis. Okay, now let's write a little bigger. So y dash equals to y subtract 1. Okay, dilation from the x-axis of a factor of 3. So what's dilation, like what's this changing this one? Y or x? Y. Okay, it's changing y, but already it's changing y here. Okay, y is changed once now, and I want to change it another time. What I can write now? Like minus 1 moving down happen first, and then do a dilation. Okay, and then do a dilation. So the sequence of transformation, okay, the order of transformation happen is the same as your calculation order. Okay, same as your not like numerical calculation order. Okay, how to do calculations? That will be the same as the order of transformation happened. So your y minus 1 happened first, and then you have dilation by a factor of a third. So y minus 1 happened first. That needs to be in the bracket, and then make a dilation there. Okay, then times a third, because y minus 1 become your original x now. Okay, suppose that's your original x. Y minus 1 is the first step happened, and then take another step, a third. Okay, what's a third? A third is dilation, but dilation should happen after the translation. So your translation needs to be done first. So that's why y minus 1 is in the bracket, and then do the dilation. Okay, then times a third on this function. Okay, so same order as your like calculation order. So what I can write is like that. So have a think. You don't want to say there are 5 transformations happen in y direction. Okay, there are 5 transformations happen in y direction. You don't want to write 5 single steps. Okay, you don't want to write, okay, what's a function give you b, and then b to c, c to d. You don't want to do that. You want them to happen at the same time. Okay, you can write one equation to represent all of these transformations. So that will be something like called a combination of transformations. Okay, something happened first and then another thing happened, and just make sure the order is correct. Okay, the order is correct. So translation first is y minus 1, and then a dilation, which is a third. So that is what you can have. So I still and we don't have anything happening x side. So what I can write is y equals to 3y dash plus 1. Y equals to 3y dash plus 1. And then I can put that into the function y change to 3y dash plus 1 equals to minus 2x minus 3 squared plus 1. So I can subtract 1 from both sides first. The 1 just disappeared. And then I can divide 3 on both sides. So that's y equals to negative a third 2x minus 3 squared. That is my kx. Kx equals to negative a third 2x minus 3 squared. Okay, then let's have a look at if without all of the steps. Okay, let's say if the question just say, okay, I'm going to change this question a little bit. So I will highlight the part I want. Okay, the graph of G is obtained from that. Okay, by a translation of 3 units in the positive direction of x-axis and translate y units in the negative direction of y-axis, and okay, not write down yet, and I will have by a dilation of a half from the y-axis and then a reflection in the x-axis. Okay, I'm just keep going. Okay, I'm keep going, and then I want then a translation of y units in the negative direction of y-axis and then a dilation from the x-axis by a factor of a third. So there are 6 transformations happen at the same time. Okay, 6 transformations happen at the same time. So I want to see what's the resultant function G. Okay, we should have the same answer as kx. Okay, we should have the same answer as kx because whether it happen at the same time or take several steps to happen will give you the same result. So let's have a look what I can do to this. So first is G is obtained from that graph by a translation of 3 units in the positive direction of x-axis. I will write it here. So I can have x dash equals to x plus 3. Okay, that's the first one. And then a translation of y units in the negative direction of y-axis. I will have y dash equals to y minus 1. Okay, that's the second step. Next is a dilation of factor a half from the y-axis. So what is changing? It's changing x. Okay, a half from y, so it's changing x. Now my x is already something happened. So if I want to further change it, that will be times a half on that. Okay, or you can times the half in the end. So, but needs to be in the bracket x plus 3 because x plus 3 needs to happen first and then a half. Okay, and then a half. And next one is a reflection in the x-axis is changing y value. The new y become negative of the old y. Okay, the new y become negative of old y. So I will negative that value. Okay, I will negative that value. And then we have a translation of y units in the negative direction of y-axis. You change y again. Okay, moving down by 1. Then you subtract 1 in the end. Okay, going down by 1 unit. So subtract 1. The last thing is dilation from x-axis by a factor of a third. So it's changing y. Okay, still changing y by a third. So all of that needs to be in the bracket and you times that by a third. Okay, a third of all of those values. So can you see? Okay, look at your notes. Translation of 3 units to the right. Okay, the first one. Translation, calculation order. Think about the calculation order. And negative direction of y-axis, you have that. And then dilation by a half from the y-axis, you have here. Okay, that's the second one. And then dilation and the reflection in the x-axis, you have negative here. And then moving y units down in the y direction, you have minus 1 here. And then dilate by a factor of third from the x-axis, you times the whole thing by a third. So all of that is in the same order of your numerical calculation order. Now what I have, you have your original function is y equals to x squared. Okay, that's your very original equation, y equals to x squared. So I still have x and y. Okay, it doesn't change. You still have x and y. Therefore, you need x and y to be the subject. So x can equals to 2x dash minus 3. Okay, and what's y? Let's have a look what's y. So 3y dash plus 1 equals to minus y minus 1. So, and you negative the whole thing, negative 3y dash minus 1 equals to y minus 1. And y will equals to negative 3y dash. Therefore, I'll do substitution. Negative 3y dash equals to, the x will change to 2x dash minus 3. And then square. Okay, that is the y position. And that is the x position. Okay, that's y, that's x. Y equals to x squared. And therefore, y will equals to negative a third 2x minus 3 to the power of 2. Okay, that's the, can you see like that's only about one page? Like it's really easy than you going a step by step. And let's check the answer in the end. Okay, it's the same answer. Negative a third 2x minus 3 squared is the same answer. So that's a combination of transformation. So there's not only one transformation for each x and y. It will be like a couple of steps. Okay, a sequence of transformation. Okay, if you're not quite get it, it's okay. We have example 2. Okay, we still have example 2. Example 2 will be exactly the type we just talked about. Example 2 says, what is the image equation for that? Okay, that's the original one. That's the original equation. Okay, that's the original equation. And the following transformation applied. Okay, the number 1, 2, 3, 4, 5, 6 is the order of transformation happened. Okay, one happened first, and then second, then third. Do not change the order of transformation. Do not see, I want to do all the translation first. Okay, pick up the translation and then all the dilation. Do not do that. It will go through the same order here. So, first one, translate 2 units in the positive direction of x-axis. X dash will equals to x plus 2. Translation 2 units in the positive direction of x-axis, x dash equals to x plus 2. Dilation by a factor of a half from y-axis is changing x again. Okay, a half from y-axis is changing x again. So times that by a half. Reflection in the y-axis. Reflection in the y-axis is changing x again. You times that by negative 1. Okay, you negative the whole thing. Okay, negative the whole thing. Number 4, reflection in the x-axis is changing the y value. So y equals to y dash equals to negative y. Okay, reflection in the x-axis is changing the y value. So new y equals to negative of old y. Number 5, translate 1 units down. Subtract that by 1. Okay, you don't have the bracket. You don't have the bracket because negative y will calculate first and then minus 1. The last one is dilation by a factor of 4 from x-axis. Is changing y again, dilates from x-axis by factor 4. So the whole thing needs to be times by 4. The whole thing needs to be times by 4. And I need to have xy to be the subject because I want to do substitution. Okay, the two things is, if you want to do substitution, you need to have xy to be the subject. if you want to describe the transformation, you need to have x dash y dash to be the subject. Okay, the difference between like the two type of questions. Okay, this is all type 1 question. I haven't really tell you type 2 one. The next exercise will be type 2. So let's finish this first. Now I want to substitute. So I need to make xy to be the subject. So negative 2x dash equals to x plus 2. I times negative 2 on both sides. And x equals to negative 2x dash minus 2. For y side, a quarter y dash equals to minus y minus 1. A quarter y dash plus 1 equals to minus y. Y will equals to negative a quarter y dash minus 1. And then I can do substitution. Okay, in the place of y, I will have negative, okay, right negative a quarter y dash minus 1 equals to bracket minus 2x dash minus 2, but you still have the plus 2 there, and then squared. That's the position for y, that's the position for x. Okay, instead of y, you write minus a quarter y dash minus 1. Instead of x, you write negative 2x dash minus 2. Okay, I will bring it to the top. So negative a quarter y equal minus 1 equals to, okay, the inside is, okay, this side you have negative 2 plus 2 is 0, and you have negative 2x squared, and the square negative 2x, and the whole thing squared equals to 4x squared. Okay, 2x squared is 4x squared. And then negative a quarter y equals to 4x squared plus 1. So y equals to times minus 4, so it's minus 16x squared minus 4. Hopefully I get the correct 4x squared plus 1, and then times negative 4, negative 16x squared minus 4. I think it's correct. Because we want to make y to be the subject. Okay, any questions so far? For this whole page, okay, 7C, this whole page is talking about type 1 question, okay? Give you a sequence of transformation, give you the original function, and I want to know the resultant function. And the sequence of transformation will happen in this order, okay, will happen in this order. So same calculation order will be the same as your transformation order. Okay, just make sure you have the correct place to have brackets. Make sure the order is correct. But like you can see, even though the question becomes complex, we still use the knowledge we learned from the previous week. Okay, it's still like translation, dilation, and reflection. Okay, still those 3 things. Okay. Do you have class tomorrow? No, we don't have class tomorrow, and we don't have Thursday. Okay, we only left 1 lesson. Why we keep losing lessons for year 11? Okay. Well, then I need to go a little bit through for 7D, and you can have like next 2 days to do a little bit revision. Just make sure you get enough practice, okay, before Friday. 7D is type 2, okay? So 7C is type 1. There will be a type 3 question. Type 3, there will be a type 3, but like that will be really easy. After I finish those two, I will talk about the last one. The last one is really easy and it's not really happen a lot. Okay, but this can be like, if I'm not talking about, you may just don't know that. So I'll talk about type 2 first. Type 1 and type 2 is the majority, like the large proportion of questions will be, okay, 99% of the question from VCA is type 1 or type 2 question. Okay, 99%. Like I not really see type 3 question. It's only in SAC or in year 12 test if they have type 3 question. So I'll talk about that a little bit. So determine the transformation. Okay, revision from last week. Determine the transformation. I need to see x dash equals to what x, y dash equals to what kind of y. And to set up this equation, okay, it's a little bit like reverse thinking. Okay, it's a little bit reverse thinking. So what I want to do is I will leave the model only on the, okay, I will distinguish between the original and the resultant function first. Give x, y, x dash, y dash. Second, I need to think about what is the model. Okay, I call this a model. So the model will be 1 over something, like hyperbola model, 1 over something. Truncus model, 1 over something squared. Square root model, square root something. Square model or polynomial model, brackets, something power. Okay, bracket, power. What else? Sine, cosine, tangent of something. So we'll learn that later. So we talk about the models. So in this one we have square root. Okay, square root. So only square root something can be on the right hand side. All else things needs to be on the left hand side. But first I need to distinguish between the original one and the resultant one. So take this graph to this graph. Okay, not always the easier one is the original one. Okay, sometimes you can say from y equals to square root 5x minus 2 to y equals to square root x. Okay, not necessarily always like the easier one is the original one. The complex one is the resultant one. Read the question carefully. So from which to which? So from that one, this is the original. To that, so that is the resultant. Okay, y dash and x dash. And the good thing about this is the model is just on the right hand side. There's no other stuff. Okay, there's no constant, there's no coefficient, so it's only this model itself on the right hand side. So therefore, I can equalize both sides. So I can equalize both sides now from this step. Because this step is good enough, I don't need to change anything, I can equalize it. Because the model is this one and this one. You only have it on the right hand side. So what I can have is y equals to y dash. And x equals to 5x dash minus 2. When I equalize the x side, I do not need to include the model inside. Okay, I do not need to include the model itself. The square root is the model. I just need to equalize the thing I insert in the model. Okay, what I put and the square root. I equalize those two things. And I need to make x dash and y dash to be the subject. Okay, I need to make x dash, y dash to be the subject because I want to describe the transformation. When I give you the transformation, you can write x dash equals to what, y dash equals to what. Therefore, when you have x dash, y dash equals to something, you can go back to the transformation. So that is the thinking. So y dash just equals to y. And x dash equals to 1 over 5 x plus 2 in the bracket. X plus 2 in the bracket. Okay, x dash will also equals to 1 on 5x plus 2 on 5. Okay, why I have those two different notations? I'll explain it. Okay, I'll explain that. So there's nothing happened to the y side. Okay, there's nothing happened to the y side. The original y still equals to the old y. So don't need to talk about the y side. So just think about the x side. Just think about the x side. Okay, from this one. Okay, from this one. What I can say is, what is the calculation order? The calculation order is x plus 2 first. Right? X plus 2 first. I'll say number 1, translate 2 units to the right. Okay, translate 2 units to the right. Number 2 is times 1/5. Number 2 is times 1/5. Then it's a dilation, right? It's a dilation. It's dilate by a factor of 1/5 from the y-axis. Okay, dilate 1/5 from the y-axis. Translation first and then dilation. What I just tell you, this answer is not wrong. This answer is correct, but like I prefer a DRT order. Okay, I prefer a DRT order. Dilation first, reflection, and then translation. So this is a correct answer. If you write that in the exam, nothing wrong with it. Okay, nothing wrong with it. But if you prefer DRT order, you will expand the bracket because in this notation, you will calculate 1/5x first and then plus 2/5. So what you can write from this one? That will be number 1, dilation by a factor of 1/5 from the y-axis. 2 is add this 2/5. So translate 2/5 units to the right. Can see both answers is correct. Depends on what form you give your x dash. Okay, whether it's in the bracket form or you in the expanding form. I prefer everything to written in the expanding form because the expanding form will exactly give you the DRT order. Okay, because you write the times first and then you calculate the plus minus. It must be dilation first and then reflection and then translation, add or minus something. But like nothing wrong with the first one. Okay, nothing wrong with the first one. If you can write the first one, they can't mark you down. But I would say because I want you to be clear for same format, just go DRT order. Okay, if you can remember, just go DRT order. Dilation, reflection, and translation. Okay, so I'll prefer the second one, but both of them are correct. Depends on what form you give in your x dash. Okay. So that's this example. Let's have a look at example 2. Okay, let's have a look at example 2. Example 2 is find the sequence of transformation which takes the graph y equals to that to that. Okay, so which is the original one? From that to that. Okay, as I said, not the simpler one always be the original one. So in this case, y equals to 2 square root minus square root 4 minus x plus 3 is the original one. And then y dash equals to minus square root x dash plus 6 is the new one, okay, the resultant one. And because that's a square root model again, I will only take square root, only those two things can be on the right. Okay, only the square root can keep on the right. So what I will have is a half y minus 3 equals to square root 4 minus x. And minus y dash minus minus 6 equals to square root x dash. Okay, make sure you have the correct, like a rearrangement. If you make that step wrong, your transformation cannot be correct. Okay, make sure you write that correct. Okay, model on the right, all the constant factors on the left. And I will equalize both sides. Okay, definitely there will happen something for x and something for y. Okay, x and y both sides. So I will have a half y minus 3 equals to minus y dash minus 6. Okay, I'll write x side as well. So 4 minus x equals to x dash. Okay, equalize both sides. What needs to be the subject? X dash or y dash or xy? X dash y dash. Okay, x dash y dash needs to be the subject. Therefore, it's negative a half y minus 3 equals to y dash minus 6. Negative both sides. And negative a half y minus 3 plus 6 equals to y dash. As I said, I don't want that into the bracket form. I want DRT order. I will expand it. So y dash equals to minus a half y plus 3 over 2 plus 6, 12 over 2. So y dash equals to minus half y plus 15 over 2. That's what happened for the y side. And to the x side, x dash is already the subject. Okay, x dash equals to minus x plus 4. I was changing the order because I want to see what happened, what times in front of x first, and then plus that. Okay, just not that confusing. If you write minus x plus 4, it's not that confusing. Okay. So, you can see this dilation is only from the y side. There's no dilation to the x side, and there's reflection on both sides, and there's translation on both sides. So the order I will talk about that will be what I should write. I should write here. So step number 1, dilation by a factor. Okay, the language needs to be correct. Okay. Factor of a half from the x-axis. Dilation by a factor of a half from the x-axis because it's changing y value. And there's no dilation in the x side. Okay, there's no dilation in the x side. So don't worry about the x side of dilation. And number 2 will be reflection. Reflection in the x-axis and y-axis. That's 2 dilation actually, 2 reflection actually. So doesn't matter which one you say first. Okay, y first or x first doesn't matter. It will be the same. Okay, you can dilate x first and you can dilate y, or you can dilate y first and then x. That will be the same result. Okay, so you dilate which side or you reflect which side first. It doesn't matter. Okay, dilation from y and then from x and then from y will be the same. Reflecting x in y or in y and in x, that will be the same. And then translation. Translation up, down, or left and right, doesn't matter. Okay, it will be the same. So let's translate x side first. Translate 4 units in the positive direction of x-axis or right. Okay, translate 4 units right. 4 is y side translation. Translate 15 over 2 units up. That's not the unique answer. Okay, that's not the unique answer. You can have more than just infinite many ways you can talk about the translation, but that will be the most preferred one. Okay, that will be the most preferred one. Okay, example 3. I will leave example 3 and we'll come back to talk about that. You can think about what you should do to this question, or tell me a reason why you think you can't do this question. Okay, why the transformation is hard to apply, or why like you think some difficulties here. Okay, what's the difference between example 3 and example 1 and 2? Just give me some idea why you think, like, if you can do it, do it. Okay, this definitely can be done. Or if you think you can't do it, have a think. What stopped you of like trying this question? Okay, so I will talk about example 3 when we come back. And we'll talk about example 4. Example 4 will be like a special type, okay, because the model hasn't been specified. Okay, you don't know what exactly is a square root function or a 1 over x function. You don't know what function is that. But we'll do the same way. We will say y equals to fx is the original function, and y dash equals to 3f bracket 1 minus x dash minus 2 will be the new function. Okay, even though the model hasn't been specified there for you, okay, you don't know what exactly is that, but fx itself is a model. Okay, fx itself is a model, so you only leave fx on one side. Okay, you only leave that on one side. So for this one, you still have y equals to fx, and for this side, you have y dash plus 2 over 3 equals to f bracket 1 minus x dash. Okay, that's actually easier than any other type of transformation. Okay, the f is so obvious, or gx or hx. You only leave that on the right hand side. So what you will have is y equals to y dash plus 2 over 3. For x side, what you insert into the function is x and 1 minus x dash. Again, you need x dash, y dash to be the subject. So y dash equals to 3y minus 2. And x dash equals to minus x plus 1. Move x dash to the right, left, move x to the left. So x dash equals to minus x plus 1. So DRT order, there is a dilation by a factor of 3 from x-axis, because it's changing the y side. Okay, 3y, so 3 of the original y will be dilation by a factor of 3 from the x-axis. And then think about reflection. There's reflection in the x side, so there's reflection in y-x-axis. Okay, negative x's reflect in the y-x-axis. Then negative x, so reflection in the y-x-axis. And then translation. Translate 1 unit to the right. Okay, x plus 1, okay, to the right. And 2 units down. Okay, move 2 units down. You can say it together. Translate 1 unit to the right and then 2 units down from the y side. Okay. Okay, I almost finished exercise D. We left example 3. You can do all exercise A to D. There may be 1 or 2 questions you can't do it, but you can do most of it. Okay, you can do most of it. So we finished exercise A to D. So you need to start to do practice. Okay, you need to start to do practice.